Okay, so in this part, we're going to look at some examples, so that might clear things up a bit more. So, the bond angle for ammonium ion. So we know that, I mean, if you don't know this at this point, it's just I'm just going to say it briefly. So the ammonium ion is this one here. So basically what happens is you have the regular ammonia, which is NH3, and then what happens is we know that to form a covalent bond, you need you need one you need each of the atoms to contribute one electron to the bond. But sometimes this might happen that you might have an H plus ion here. So an H plus ion doesn't have any electron at all. So this guy cannot form a bond. So say, imagine it like this, that you are going out to eat out with your buddy. You're going to get a hamburger, but your buddy doesn't have any money. So you guys cannot go together, but you have some extra buck. So what you're doing here is you're saying that, well, I'll chip in for you. Let's just go together. So this is you, and this is your buddy with no money, and you want to go together and eat out. So what's going to happen is, so you are lending him the money. So here, this is your money. So you are doing both the part. You're giving that guy the electrons. So what's happening is, so you have the ammonia, and then you have the hydrogen, then you have the hydrogen. So the way we represent, all right, so we're going to give an arrow here. So that means that the lone pair was given to this hydrogen to form this bond. So this whole molecule is going to have a plus charge, because if you count the number of electrons and the number of protons in each of these atoms, you're going to see that one proton is extra. That means that is because this hydrogen came into this system with one proton but no electrons. So this whole system has one extra proton, then it has electrons. That's why you have a plus charge. So anyway, so we're done with that. So now let's look at this. So we need to remember that charges do not contribute anything to bond angles. So it has a charge. I don't care. I mean, for the bond, to figure out the bond angle, I wouldn't think about the charge. So what you're going to do is you're just going to concentrate on the number of lone pairs and bond pairs. So this is a dative covalent bond, right? If you do not know this type of bond is called a dative covalent bond. Or you could say it's a coordinate bond. It's also called a coordinate bond. So basically, you're just helping your friend here. So anyway, so that's also is a regular covalent bond. We're going to consider them as regular covalent bonds. So, so, so in ammonium ion, so nitrogen is the central atom. So I'm going to figure out the number of lone pairs on nitrogen. So number of LP on N is going to be the group number of nitrogen. Nitrogen is in group, let's check it out here. Oops. So nitrogen is in group 5. So, okay. So I know that in NH3 there was, so if group 5 minus, let's do the number of bonds formed here is going to be 4 divided by 2. So you can see that you get a fraction. So this doesn't make any sense. So there are no lone pairs, basically no lone pairs, because you need an integer here. The reason is you have to understand that you have given that electron to the H plus ion, to the proton, for this. So there are no lone pairs present in NH4 plus. So now I have the nitrogen, which has a dative covalent bond with this hydrogen and a regular bond with this hydrogen. I can draw a 3D diagram, or I could just like draw a normal one, doesn't matter. So if I'm drawing a 3D, it should look like this. Okay, so I have no lone pairs and I have 4 bond pairs. So I'm going to go up to this thing which you should memorize. So this is tetrahedral. 4 bond pairs, bond angle 109.5. So this shape is going to be tetrahedral, and the bond angle is going to be 109.5 degrees. Oh, I forgot to put a plus, so let's just put them here. It's a plus. Okay, so these angles are all 109.5 degrees, all of these angles. So this bond angle is between, like, you pick any bond pair of electrons and the angle between them is going to be 109.5, any bond pair. So this is a bond pair, and just randomly pick, say, this bond pair. The bond angle between these two guys are going to be 109.5. So it's 3-dimensional. So okay, so now let's see water. So the bond angle in water, H2O. So I know that water is in the middle. So I'm sorry, oxygen is in the middle, and you have 2 hydrogens. So the number of lone pairs in oxygen. Okay, so oxygen is in group number 6. Minus, you have 2 bonds, so minus 2 divided by 2. So you have 2 lone pairs on oxygen. 2 lone pairs on oxygen in water. So there are 2 lone pairs in oxygen, and these lone pairs repel the bond pair more, right? So they're going to push it and squeeze them in. So these guys, let me change the color here. So what these guys are going to do is, these lone pairs are going to push this bond angle and squeeze them. Squeeze them until they look something like this. So in A levels, we don't worry about the bond angle between these 2 lone pairs, or we don't worry about the bond angle between this lone pair and this bond pair. We just care about the angle between the 2 bond pairs. So this should be, so okay, so now to figure out the bond angle, so we have 1 lone pair, 2 lone pairs, and here 1, 2, 2, I'm sorry, we have 2 bond pairs and 2 lone pairs. So we have 2 bond pairs plus 2 lone pairs. So we have total 4 electron pairs, right? So for 4 electron pairs, the shape is going to be tetrahedral, and the angle is going to be 109.5. But we have 2 lone pairs. Remember that we subtract 2.5 degrees. Here it is. We subtract 2.5 degrees for each lone pair. So we have 2 lone pairs here. So the bond angle. So the bond angle is going to be 109.5 minus 2.5 for one lone pair and 2.5 for the other lone pair. So the bond angle is going to be 104.5 degrees. So this is 104.5 degrees. And the shape is called V-shaped. You're going to call it V-shaped, or you could call it bent shape. So that's that. These are the 2. Use either one of these names for water. So that's that. Or anything that has a bond angle of 104.5. So another problem could be the bond angle in CH4. So right away I know that carbon is a central atom. So carbon is in group 4 minus the number of bonds formed with hydrogens are 4 divided by 2. So I have no lone pairs, 0 lone pairs. So the 4 bonds, the 4 electron pairs are bond pairs. So it's pretty straightforward. It's going to be tetrahedral. So it's going to be tetrahedral, and the bond angles are going to be 109.5 degrees. The shape is tetrahedral. There you go. Okay, so now the type you might see in the question paper is that of hydrogen peroxide. Okay, and they might ask you about the bond angle of HOO. So this basically means they're asking about this bond angle. So they're asking about this bond angle. So right away I know that in this case I'm just going to focus, I'm going to forget about the whole molecule and I'm going to focus on this particular bond only, right? So I just care about this portion. So I only care about this bit. So what I'm going to do is, I'm going to figure, this is my central atom now in this portion, inside this portion. So in this central atom, what I'm going to do is, I'm going to figure out the number of lone pairs in that oxygen. So the number of lone pairs in that oxygen is going to be, oxygen is in group 6 minus number of bonds formed. This oxygen has 2 bonds, right? One here with this hydrogen and one here with the other oxygen. So that's the 2, and then divided by 2, that's the formula. So I have 2 lone pairs. So the lone pairs are probably here. So there you go. Those are the lone pairs. And so I have 2 bond pairs. I have 2 lone pairs. So I have 4 electron pairs, just like the case in water. So I have 4 electron pairs. And for 4 electron pairs, the bond angle was 109.5 degrees, but I have 2 lone pairs, so I'll subtract 2.5 degrees minus 2.5 degrees to give me 104.5 degrees. So this X, oops. So this X was 104.5 degrees. So that's that. So you might also be asked about the bond angle between, say, okay, let's draw this molecule out. So let's say CH3, CH2, CH3. And they're asking about the bond angle here. So they want to know the bond angle here. So this one. So what we're going to do is, we can draw it out. Let's draw the displaced formula to see better. So this is an alkane, right? Okay, so we are going to focus only on this bit. Central carbon atom is my focus and the bonds it has formed. I don't care about what the other guys are forming. I care about this guy. This is my central atom, right? So my central atom, this carbon, is in group 4. Minus, it has 1 here, 2, 3, and 4. It has 4 bonds. That divided by 2 is 0 lone pairs. This carbon has no lone pairs. And it has 4 bond pairs. So the bond angle, CCC is 109.5 degree. And the shape is tetrahedral. So other common type of bond angles that you might encounter is, let's say, BeCl2. Okay, so in this case, the bond angle, so beryllium, let's check out where beryllium is. So beryllium is in group 2. So beryllium is in group 2, and so let's figure out the number of lone pairs in beryllium. So we know that beryllium is in group 2, minus it has two bonds with 2 chlorines. So minus 2 divided by 2, so that's 0. So it has no lone pairs. So as it has no lone pairs and only 2 bonds total, so we know that from this theory, you have beryllium here, you have 2 chlorines on 2 edges, 2 sides. So it's going to be 180 degrees, and the shape is going to be called linear. So one thing I didn't mention is this whole thing here, these guys, these 5 theorems or whatever you call it, these are called valence shell electron pair repulsion theory. So this is what they're called. Okay, so let's get back to this example. So this is going to be, the beryllium is going to be in the middle. You have 2 Cls on 2 sides, and this bond angle is going to be 180 degrees. The shape is going to be linear. Another common type of problem, common like compound that you might see, is going to be PCl5. So for PCl5, phosphorus is in group 5. It forms 5 bonds, so no lone pairs. So I know that for 5 bonds, you are gonna have the shape called trigonal bipyramidal, right? According to the valence shell electron pair repulsion theory. So these bonds, these form a triangle, right, in a plane, in a flat plane. So the bond angle between these guys are 180 degrees, right? Sorry, 120 degrees. And the bond angle between this chlorine at the top and this chlorine at the bottom with the flat plane is 90 degrees. It's 90 degrees. So this is called trigonal bipyramidal. And the bond angle is going to be 90 and 120 degrees. The other common type that you might see is called SF6. So sulfur is the central atom. If you figure out the number of lone pairs, sulfur is in group 6 minus the so sulfur is in group 6 minus the number of bonds, which is 6 divided by 2, 0 lone pairs. So when you have 6 bonds, you know that sulfur is at the middle, and then you would have a fluorine there, a fluorine here, a fluorine here, and that's that. These angles are all 90 degrees, and the other 2 fluorines are going to be at 90 degrees to this flat plane. So the bond angles are 90 degrees, shape is octahedral. So now we're going to look at something different, say carbon dioxide, CO2. So right away I know that carbon is the central atom. So the way CO2 electron forms the bonds, it has double bonds with each oxygen, right? Because carbon needs to have 4 bonds, and each oxygen needs to have 2 bonds. So this satisfies that requirement. So carbon is in group 4, so the total number of bond it forms is 4. So there are no lone pairs, 0 lone pairs. But wait, these are not single bonds, these are double bonds. So what's going to happen? So in this, to figure out the bond angles, we really wouldn't care about double bonds. We're going to treat double bonds, it's very important, we're going to treat double bonds just like we treat like any other single bond in this like VSEPR theory. So we're gonna treat this guys, we're gonna imagine that this is a very thick single bond. Very thick single bond. And there are no lone pairs. So this becomes just like BeCl2, right? So the CO2 should be exactly like BeCl2. So what we're gonna say is the bond angle is 180 degrees and the shape is linear. But of course, never draw it like this.